We define simple harmonic motion by stating that it occurs when acceleration is proportional to displacement from a fixed point and in the opposite direction. So it's not jumping, because when you jump, the force pulling you down is constant. It's your weight. It's not proportional to the height you jump. We tend to think about mass spring oscillators. So for a spring, since F equals kx, force is proportional to extension of a spring and acts in a direction opposite to the direction of extension. So a mass spring oscillator can be an example of simple harmonic motion. Now we really want to think about the acceleration in this, and we know that x equals x naught sine omega t. So if you differentiate that, the derivative is going to be equal to x naught omega cos omega t, and the derivative of that is equal to minus x naught omega squared sine omega t. Rearranging it slightly, that's equal to minus omega squared x naught sine omega t, which is equal to minus omega squared x from the start. Therefore, acceleration is equal to minus omega squared x. And this is often considered the defining equation for his simple harmonic motion. So, simple harmonic motion occurs when acceleration is proportional to displacement from a fixed point and in the opposite direction. And omega squared is the constant of proportionality. You might also notice that x, v and a are all 90 degrees out of phase.